Good morning, everyone. I'm Michelle Sanner, and today we are going to start learning about the different types of chemical reactions that we as chemists can classify. And the two we're going to discuss today are titled synthesis and decomposition reactions. So by the end of this morning, I would like you to be able to distinguish between a synthesis and a decomposition when you're given a full and complete chemical equation. So using this idea of using the reactants and using the products, comparing and contrasting, and identifying what type of reaction that you have. So we classify chemical reactions by their similarities, the ways that they're similar to one another. And overall, we're going to study 5 types this year, but we're only going to look at 2 today. The synthesis, that is pulling together of different molecules or elements to form a larger, more complex compound, and decomposition, where that larger, more complex compound breaks down into 2 or more substances. Starting with a synthesis reaction. In a synthesis reaction, which is also known as a composition reaction, 2 or more substances are able to combine to form a new compound. Now, the substances can be elements, so something that's as simple as a single atom, or they can be whole molecules, compounds, but they would come together. A and X then represent those smaller, simpler substances that come together to form, and this is a generic term, AX. And these are not real atoms, these are not real chemical symbols, these are just there to give you an idea of generally what's happening when these synthesis reactions take place. Here's an example of a synthesis reaction, and I'm actually going to show you this first one here. Magnesium, which is a solid metal magnesium, is a monatomic element, meaning it only has one type of atom, one atomic atom. And it reacts with oxygen gas, which is a diatomic element. So di, 2 atomic atom, 2 atom molecule there. And it's a synthesis reaction because these 2 simple substances come together to form a relatively more complex substance, magnesium oxide. Here's another example, calcium oxide, a compound made up of calcium and oxygen, is combined with water, liquid water, which is also a compound, 2 or more substances, and they come together to form calcium hydroxide, a slightly more complex molecule. So this is a synthesis reaction between 2 compounds. So let's go ahead and look at an example of a synthesis reaction. So I'm going to show you a video that I made the other day of the synthesis of magnesium and oxygen to form magnesium oxide. So what I want you to look for in this video, tell me, where does the oxygen come from in this reaction? What is the leftover? What is the product? And what evidence do we have from that list of 4 pieces of evidence that you can use to determine a chemical reaction? What evidence do we have that a chemical reaction took place? All right, let's take a look. All right, so here we have the magnesium, solid magnesium. It's metal, as you can see. It's shiny, it's lustrous, it's malleable, ductile, it can be moved and manipulated. This is just a coil of solid metal that I have. So I'm going to ignite it, and this is a metal that you could see commonly used in fireworks, and you'll see why in a second here. It's quite bright when it's ignited. In fact, it's so bright that when you're in person with this reaction, you can't even look at it without damaging your eyes. So the magnesium is burning. Where is the oxygen coming from? What evidence do we have that a chemical reaction is taking place? And take a look at the product and look how different it is in terms of its composition, in terms of its properties. You could see it's no longer malleable or ductile. We've got a very chalky, white, solid, easy to break up, very brittle. So something very different from the flexible metal that we started with, and no longer lustrous either. So that is the synthesis of magnesium. The next type of reaction that we are going to look at is called a decomposition reaction. Now, in a decomposition, this is almost the opposite of a synthesis reaction. A single compound undergoes a reaction that produces 2 or more simpler substances. So you're taking something that's more complex and breaking it down into smaller, simpler substances. A general formula with A and Z as placeholders for real elements is taking something like AX, at least a 2-atom molecule, and breaking it apart into its more simple, smaller components. Remember, A and X can be elements or compounds, but this AX that you start with must be a compound composed of 2 or more different types of elements. So a couple of examples of decomposition include carbonic acid here, aqueous carbonic acid decomposing, breaking apart into smaller, simpler substances, carbon dioxide gas, and H2O. And we've also seen in class the other day, the decomposition of water. So a substance that is decomposed by an electric current, we call this electrolysis. So this is the decomposition, or another way of saying it is the electrolysis of water. So let's take a look at that again. Okay, so what I have here is a large battery. Positive and negative ends here. I've got a glass full of water. It's a little bubbly because it just came from the sink. And I put 2 metal push pins in the bottom. And I'm doing that. I want to make sure the bottom is dry. I don't want any water to touch my battery here. Now, once I start running a current through it, we're going to start to see water breaking down into its smaller, more simpler substances. So I'll just put it right here for you. So placing the dry metal here, I'm sure you can see it, right there on either end of the battery. We start to run an electric current through the water, and we're able to see tiny bubbles coming off of those tips there. And those tiny bubbles are our simpler, smaller substances, our hydrogen gas and our oxygen gas. And so that is the decomposition of water by a method called electrolysis, a special type of decomposition that involves running an electrical current through a substance. So I'd like to show you one more demonstration today. But this demonstration is so hazardous that I don't even want to do it in my lab. It's the decomposition of sugar or sucrose with concentrated sulfuric acid. And my questions to you as you watch this video are, where's the water in the product? And what do you think the black stuff is? What evidence do you see that shows a chemical reaction has taken place? Now, credit where credit is due. I want to make sure to point out where I got this demonstration from. Here's a link and a citation of all the folks involved who did this for us. So let's take a look. All right, so you can see a large column of solid carbon is formed by the decomposition of sugar here. Look at all of the steam coming off the reaction. Now, this isn't just pure water. This is water mixed with acid, which is why it's such a dangerous reaction to do. And we don't typically do it in a high school setting unless we're working underneath the fume hood. So another example of decomposition reactions. So that's it for today. I hope that you learned a little bit about the difference between a synthesis and a decomposition reaction. The next time we meet, we're going to look at some different chemical equations and practice identifying, is this a synthesis or is this a decomposition reaction? So I hope you're doing well and you're having a great day, and I'll see you soon.